Thank you very much. I am Mark Ouska, and I would like you to imagine a world where you have an enterprise schema that your data can use to self-assemble, where you don't have to worry about reserving space for data that may or may not show up, and if data that you weren't expecting shows up, it's no problem. Does that sound like a revolutionary idea? It's not a world I used to live in before I came to semantics. However, what we're going to talk about today is semantic knowledge graphs. This is my focus. And agenda for today, what unique, globally unique identifiers are and how they allow data to self-assemble. When I first came into semantics and somebody told me that, I was like, yeah, right. And there's a tooth fairy too, right? Design time versus runtime logic, and no nulls required. Now, might not be a big deal, but it might be a huge deal. So we'll talk about that when we get there. And Copernicus, everybody knows who Copernicus is? Fewer hands than I was hoping for. Copernicus is the individual who identified that, in fact, the Earth spins around the sun, not the other way around. So before that, there was all kinds of mathematical calculations to figure out how are these planets spinning, and Mars would go into retrograde and all these bizarre things, and they honed a lot of things around mathematics from that false assumption. But suddenly, when they switched it around, everything snapped together. And snapping together is what we're going to talk about in the world of semantics. Now, just to get started, who has worked with or heard of semantic graphs? All right, there's a couple different kinds of graphs out there. Semantic knowledge graphs are not the same as property graphs. Our focus is going to be on semantic knowledge graphs. And just to identify what the difference is, we have, this is our triple. This is what we're going to be working with. This is basically the only structure that we have to deal with in the semantic world, or in graphs in general, actually. And knowledge graphs, semantic knowledge graphs, have an ontology. This is the schema that defines what the sets are that are relevant to the data area that you're working in. There's URIs, universal resource identifiers, and you can only make statements about the things on the end. Okay, so that's a semantic knowledge graph, and it's likely not the one that you've heard the most about, because more people are familiar with property graphs. Neo4j, anyone? All right. This is not Neo4j. That's not what I'm going to be talking about. That's not to say that that isn't an exceedingly powerful technology that you can do all kinds of things with. But we believe it's kind of the training wheels to get to knowledge graphs. And the reason I say that is that we have an ontology that you can enhance as you learn more about your data environment. And with the universal resource identifiers, you can keep track of the things about which you are making statements. So these carry it into the future much better than the property graphs, which are more about path traversal and finding out who's next door, those kinds of things. So just to get that out on the table, key point is that if you start with a semantic knowledge graph, you are able to export your data and do the property graph work. So you might be better off starting with a knowledge graph. But spoiler alert, these two technologies are coming together. And so in not too long from the point that we're at this point, they're going to be combined. Okay, so that's something that's in the future. That's just a spoiler that I'm telling you about. I'm not going to go into the details of that. But it's something to keep in mind that the focus that I have is knowledge graphs and the power that you can get from them. Why would we care? If you look at these organizations here, these are the top 10 organizations in the world by market cap. And all but one are using knowledge graph technology, okay? So I think actually, if you look at Berkshire Hathaway, that's kind of the proof that you don't have to do this, because I think they're relatively successful, right? But all the others, they're using knowledge graphs in some way or another, right? So that's where we're focused, and there's a big investment. This is the future, and I think that this is a good indicator of that. Questions as we go along. I love questions in the middle. I will cut you off if you go too long, but I like to have some interaction. So, anything?
So our knowledge graphs, something I still see IBM in the middle, something like Watson used in AI? Or?
Excellent, yes. There is a knowledge graph behind Watson. That's how Watson worked. And it's the way that the connections were made. They don't happen to be on this illustrious list here is why they're not on there. It turns out that there's so many organizations now using knowledge graphs that I would spend the rest of the talk just saying their names, right? So it's very pervasive out there. That's a great question. That's a good example. So globally unique identifiers allow data self-assembly. Another question?
Well, I was curious, so does the subject that the knowledge graph is pointed at, is it aware that there's something associated with it?
I'm not sure I'm understanding the question.
So my understanding based on your slide is that a knowledge graph is something that I associate to a parent object of some type. So I'm providing additional content or context about some data element somewhere.
I'm not completely sure I understand the question, but tell you what, let's put a bookmark in that, and if that's still a question when we get later on in the program here, then raise your hand and say you're not really getting it.
The question is, well, if I understood it correctly myself, that you had the subject pointing to the object, right? Does the object know that there's a subject pointing to it as well? So is there some symmetry?
They have independent existence. So if that's the question that you're being asked, they have independent existence. In fact, all three parts have independent existence. Very important concept. We're not going to get, that's a little down into the weeds for the presentation today. I'm assuming that my audience here is fundamentally architects. I don't know why I'd think that at an architecture conference, but that was just kind of what I thought I'd go with. And so there'll be less weeds and more broad perspective, but it is true that they are independent. So here we go. So open standards. People have probably heard of Tim Berners-Lee. He invented the World Wide Web, for one thing. And he came along and said, you know what, wouldn't it be interesting if we had linked open data where the data that we're working with has the ability to be linked and connected, and the connections don't know that they're being made, so the data itself is unaware of it. There's no mechanism for that. But they proclaim their identity, and anything that is about that will snap together. And we'll see examples as we go forward on that, okay? And everybody in this room uses this technology all the time. You may have used it to find your way here if you used Google Maps, right? Because they use knowledge graph technology. We'll talk about that a little bit. The unique identifiers guarantee that the thing that you're talking about is globally unique. How many databases have globally unique identifiers and tables? 0, right? It's not inconceivable that you could have done it, but it's exceedingly rare to the point I've never seen it, 30 plus years. Do you have a question? Okay. So there are open standards out there. RDF, Resource Description Framework. I'm not going to read all the slides here, but these are standards that are the foundation for this. And in this particular case, this is the way that the information gets materialized. OWL is the web ontology language. This is what you use to create your schemas. This describes the sets of data that you're interested in. And this query language here changes up a little bit. It's called Sparkle. And anybody used these technologies, OWL or Sparkle? All right, excellent. A couple familiarities in here. That's good. May or may not have heard of this, but most of you in the architecture world will have understood that there's provenance. You need to understand from where things came, and there is a standard in this stack that supports that. So you can identify, you can actually tag each data element with its own personal provenance. Fascinating concept. I won't go into the details of how you do that, but it is a possibility. And another standard that's out there, the list is much longer than this, but the Simple Knowledge Organization System, a thesaurus capability that is part of the standard so that you have the ability to say, oh, there's something greater than me and there's something more specific than me, right? The generalization versus specificity. So these standards are out there and they drive what's going on. And it's important to keep in mind, because these standards are there and this technology is moving forward, standing on the shoulders of these technologies, you get a great deal of flexibility, portability. Okay, so how does this actually work? Well, the structure that we have is the triple, RDF. And we looked at one, we'll go into this. It's the key to flexible data structures because all you have is this simple statement, right? There's globally unique identifiers so that things are globally identified and you can carry that knowledge forward knowing that I am actually talking about Elvis Presley always and exclusively. And When I say that, I mean the guy who was the musician, not the guy who washes the car down in the corner.
Okay.
Right? So you can disambiguate between those. This is a really key understanding. This is what allows data to snap together. When I talk about self-assembly, when you put data sets together and view them through the ontology, which is the schema, things will just automatically say, oh, I'm a member of that set. You don't have to do all of the manual creation of what those sets are, okay? Description logics, this is the mathematical foundation of how you describe what that set is. Set membership is described with formal logic, and this is the tool that we use for that. And modular ontologies. You remember that time when, just as an experiment, you took your Oracle data and you ported it over to IBM and just ported the schema over directly, and then you did that in an afternoon, and then the next day the organization ran on the new. I'm getting looks like maybe nobody's done that. Of course not, right? That doesn't happen, but that is a possibility with the technology that we're talking about here, okay? And we'll go into that a little bit. Very little pre-existing structure, triples, that's all you got. Facts asserted as small sentences, right? So Dr. Jill gave care to John Doe. Anybody find that confusing? It's just a simple fragment of information, and we can look at it and say, yeah, that's likely to be true. We can say also that, and I don't know why we're keeping track of the age of the doctor. That seems maybe a little incorrect here. But we've identified information. So carrying it forward, we're building graphs. So we were just looking at a graph. The graph has edges and nodes. The edges are the circles. I'm sorry, the nodes are the circles. The edges are the lines, the connections between them. It's the objects connect by their edge. So that's what the line is. That's why it's called. Anybody have mathematics background and has worked with nodes and edges? Okay, a couple people. That's what it is. Edges are the predicates. And so here we go. It's this again. So just to make sure it's clear how this is working, when I talk about the snapping together, if you look at a Tinker Toy, we have this thing that is made to have connections, right? You can plug all kinds of stuff into it. Now, you can plug more than what Tinker Toys can, but when we do that, we call this an object property. And everything in there has its own independent existence. We'll delve into this a little bit as we go forward, but these are all the way the information is connected. Or you can have something that just points to something. Okay, so you point to it and you say that we have this literal, this is a data type property. So there are some things that are not objects that can be connected to other things, because what can you say about 57? You can't. It's just 57. It's a literal. There isn't anything else you can say. But when you have your individuals, you can say all kinds of things about them in addition to the connections that you're seeing there. Okay? So why would we care about linked open data? This is a depiction of a cloud. This is outdated. They actually stopped doing this because it won't fit on a paper and have anything other than a solid black mass. Right? There's so much open linked data out there, it's impossible to depict it. And just to give you a sense of scale, DBpedia, I don't know if people are familiar with DBpedia. This is an effort that basically scrapes all the information out of Wikipedia and puts it into a triple store. You can go and interact with the Wikipedia data running Sparkle queries to get your own insights. And that has 3 billion triples in it, and it also is just that little tiny dot right there. So if that's 3 billion triples, how much information is there out there currently? And like I said, this is way outdated, that there's far more than what can be depicted here. So this is something that is huge. You can build systems today, and people do this, where they tap into information that shows up on their forums that is actually sourced from Wikidata, right? So you can go out and reach out to data, and it's free. You just grab it, put it on there. News organizations do that a lot. All right, so here's the semantic mind shift. Question?
Is that DBpedia, is that all hand curated, or is it?
It is not. It is not. Who wants to volunteer to hand curate 3 billion things? Oh, we have one guy who wants to do it.
There is curation involved though, because it's from Wikipedia.
Yes.
And Wikipedia's curated.
Yes, Wikipedia is curated, and it's not totally automated. I can't give you the specific details on what the curation is, a little out of scope. But there is curation that happens. It's not human intervention.
It is quite fun to play with.
It is very fun to play with, yes. Many evenings and weekends have gone away in my life because of this capability.
Mark, like a decade ago, when OWL and RDF were kind of bubbling up and getting popular, there was kind of this burst of everybody creating their own ontologies. Was that previous image, like they were bringing that all together? Because like the medical industry kind of created one, the financial industry created one, and they were all sort of independent of each other, but.
So there's always somebody in the crowd who mentions the dark underbelly of the fact that not everybody is doing this in the same connected way. So yes, absolutely, just like any other human endeavor, all kinds of people all over the place are creating ontologies and data sets that may or may not connect to each other directly. They may not be considering what's going on. Or, pick on my favorite ontology that's out there. Is anybody in the healthcare field familiar with SNOMED? Okay, our opinion, SNOMED is a case study in how to do an ontology in the worst possible way. Okay, and the reason for that is that they've made it so large and bloated, it's impenetrable. All right, it doesn't have to happen that way, but there are many things that are out there. The good news is that even though they didn't do it really well, you can still tap into it and use it. All right, so that's the good side, is that there are all kinds of efforts going on out there that are not done as effectively as we believe they can be done, but we can still tap into them and make value out of them. Okay, make sense? All right, so strategic differences. Semantic meaning drives everything. All we're doing with semantics, anybody look up semantics? You know the meaning of what an ontology is, for example? An ontology comes from philosophy. It's the study of meaning. Okay, so that's what we're doing, is we're studying meaning. Everything is pushed forward from that. Meaning is encoded with set theory logic, right? So this group of people here is the set of people who are attending this session, right? Are there any bicyclists in the room? All right, now there's a subset that we just automatically, they self-assembled into their own set. That's a different set. That's a subset of the group of the people in this room, right? And there's a superset of people who are attending this conference. So when you start to think in terms of set theory rather than table structures, a lot of interesting possibilities open up. Does that make sense? Okay. And the set membership is assembled by the machine. Okay. Not going to go into this in a whole lot of detail, but in fact, the machine can look at it and arrive at the same conclusion that humans can. That's the power behind the ontology, is it identifies what set membership criteria is. So the criteria for being a member of the set of people who are in this session and are bicyclists, just they automatically are in the set. I don't need to do any joins. They're just in that set because the definition tells us that they are. Okay? Does that make sense? Kind of a challenging concept to figure out. Okay, so tactical differences. Structure is nearly irrelevant. Triples for everything. There's a couple of other structural components, but we won't get into them because the triple is really the core kernel, the atomic chunk that we work with that carries things forward. Okay? Schema reuse. I already talked about this a little bit. Do you think that it would be valuable if you could create a subject area and then from that point forward, every system in your organization would use the definitions of that subject area in any systems that came along? You wouldn't have to do that exercise again. You might tweak it and adjust it, but you could simply take and consume that. So that schema would be in multiple systems running effectively. Does that sound like a good idea? From my background, it sounds impossible until I came to semantics, but that's how it works. Okay. Schema portability, build it. We do this all the time. We'll go on client site and they'll have something behind the firewall that we can't necessarily get easy access to. And so maybe they have Stardog in the background and we develop the ontologies, test everything that we do in Allegrograph or MarkLogic or whatever it might be and make sure everything works. Then we just drop it over on a different platform that's in their production-ready system. Obviously, they're going to go through the same cycles that any good architecture does. But it works on that other platform virtually identically. All right, I say virtually because every once in a while, of course, there's a couple tweaks here and there. Some standards delivery varies between vendors, but fundamentally, you can just go back and forth between different vendors with very little change. Okay, but everything doesn't change. It's not like we're throwing the baby out with the bathwater, right? We still need to understand what our problem domain is. We need to determine what data set we're going to be looking at to solve that. Is it customer inventory? And when we look at it, what entities are we going to need to define? What sets do we need to describe in the case of customer? Well, I'm guessing customer would probably be one of them, right? What are the other ones? And how are they related to the other things that we know? So we still have to do those things that we always ever did, right? We end up articulating the solution differently, but we're still solving the same sets of problems that we always have. Semantic search breakthrough. Google. How did Google get to be so powerful with their search algorithm? People know the answer to this one? They went from keyword search to using a semantic knowledge graph. And all of a sudden, their results were just astoundingly better than anybody else, and all the other search engines were left behind. And the reason for that is that all of the information in a knowledge graph is linked. You pick something up, it's like picking up a mobile. You pick it up, this one thing you're interested in, and everything else is simply connected to it. You don't need to do any joining. You don't need to be looking for these things. They are connected by nature of the knowledge graph. All right? So that's what got Google going forward. Well, then Apple came along and said, hey, hold my beer. We're going to do voice recognition. There is a knowledge graph behind Siri. Now, invariably, somebody in the audience says, yeah, but Siri's not really coming up with great answers at this point. Nonetheless, that's the technology that made it, and when it was a breakthrough product, that was what drove it forward. Here's another one. This is an organization that we've done a lot of work with. We have been working with Morgan Stanley for a long time, 3 years, a little better than that, and we created their upper ontology. We have an upper ontology that we delivered and customized for their environment. And that's the foundation of this. I don't know if people have come across this. This was in the news recently, sometime August, September timeframe, I don't remember exactly. But the point is that analysts in financial organizations have their own language, and you and I don't know what that is, right? All kinds of bizarre terms. I can't even regurgitate to you what those terms are. But they have this whole language. Well, what does that mean? That means when a new analyst comes into the organization, they need to learn it. How can they get them up to speed on that? They use a knowledge graph that is linked with a natural language processor, right? So it can scoop out the information. Oh, when they say that it has this, you know, it's a bull market, probably you know what that is, but it interprets, well, that means that things are getting a little tougher, stocks are dropping, et cetera. And for all of the different things that are going on in the financial world, they have this vocabulary. And the translation is being done with this knowledge graph in the background. It's pretty fascinating stuff. Their perspective is that this is going to change the financial industry. So, interesting article to go look. Yes?
Going back to Google, from my understanding, it really doesn't do semantic search in any way, right? I mean, it's just mapping, so it has something like a graph structure and mapping words to pages that those words occur on. But if you type in bank, for example, it doesn't know whether you're referring to Morgan Stanley possibly, or the Bank of a River, or aircraft banking. It's just in the context of other words you might type in that it will be able to say, well, because of these different words come together on a particular page.
I think you're about to say something interesting because I don't agree with what you just said, but what are you going to say?
Yeah, there was a time when it was true. Today, you matter in the search. So if every person in this room types in the word bank, we'll get different results based on what we individually have been looking for, because they use the context of you in the graph as a part. So this is how they're able to take the same word that means completely different things in different taxonomies and in different spaces, and they can guess based on what you've been doing and working on and the other things you've been searching for. You've been trying to, you search for something, you don't find what you're looking for, you search again, they know you didn't find what you were looking for, right? You looked at 3 pages, you came back, and it jumps you across the graph into a different semantic context.
Absolutely.
Context is
Absolutely.
something
So the
that
context is completely different. So they scraped keywords originally to seed the data that was out there, and then they've used behavior in order to create the context and the semantic relationships over time. So
Well, what you're saying is correct. However, a profile of the categories that you're interested in is not necessarily deep semantic knowledge. So, for example, Google doesn't fundamentally know the difference between a fiduciary bank, a brain bank, and a river bank. It can only do pattern matching based correlations to stuff that you have searched for. So that's where the distinction is. Even though it's knowledge.
I'm going to jump in here because you guys could be taking over the presentation and then I won't get paid. The fact of the matter is that there are these connections that are out there, and what is being attached initially, my initial objection to your statement of you described keyword search to me with just a little bit of finesse on it, and context is everything. And so if you're looking for something, if your context is financial industry, then you get things that it does know the difference between a river bank and a financial bank, you know, the different categories. It does, in fact, understand that because it understands the context. And it will pick a different context in the event you're not getting the answers. If you repeat the same search with a couple different words, it goes, dang, didn't do that. What could they be looking for? If I go out on, actually, anybody, you go out on Amazon, don't you get suggestions for things that you've searched for before? You might even get suggestions for something that somebody on Facebook told you about and you clicked on, and all of a sudden you're now getting, a friend of mine told a story about some squeaky duck or something, dog toy, that just showed up in his searches for months. He doesn't have a dog, doesn't like dogs, doesn't care for dogs, but it was in his profile, the context of who he was suddenly included this thing. Okay, fortunately we've gotten a little better about that with the algorithms, but that's fundamentally what it's doing, is that you look for this product, well, what have you looked at that might lead us to that? And oh, by the way, who else looked at this product? And what would they want? Because it's in their graph. And if they looked at this product and bought something else, so these are the kinds of connections that they're able to make with the semantic environment, okay? Fascinating stuff, in any event. So design time versus runtime logic, early binding, late binding. Runtime logic, so we have a structure-first approach. That's what everybody in the room started with, I'm assuming, unless somebody started with semantics directly. That's a very short list, there are people. In my experience, 30 plus years data architecture, I built structures, that's what I did. It's grounded in physical thinking, three-dimensional thinking, right? You need to have these different size containers for the information that you've got. Maybe you've got things that you want to be able to stuff into small, you know, maybe something big, different things that you're going to do with it. You're building all kinds of point-to-point connections for you to get access to this information. But it's grounded on physical thinking that I must have a bin into which I put whatever it is I'm managing. Well, you've got 3 dimensions there. We're more than 3-dimensional, but you can't build something like that physically. Now, I'm not saying you don't understand that, but that taints the way we think about information. We're thinking about it in a 3-dimensional model when conceivably we could have thousands of dimensions. I know there are thousands of dimensions out there, right? Myself, I'm a husband, I am a pet owner, I am a presenter, I'm an ontologist, I'm a bicyclist, I'm a skier. These are all different angles. These are different dimensions to who I am. And this is true for virtually everything in life. You can't represent it when you have everything in its physical space because we don't think that way. Okay? Makes sense? Not sure if people are going, God, what? I always like to check in. This is kind of a big deal. So structure first, these are proprietary solutions, right? You're not going to pick up your Oracle database and drop it on DB2 in an afternoon. You're just not. It's not going to happen, right? You're going to go through all kinds of exercises. Most often, an exercise like that is going to take months, sometimes years. Sometimes it gets abandoned. So there's a lack of portability. You have to have the vendor-specific skills, right? We need a DB2 DBA, right? That's what we're looking for. Because you have to. You have to have somebody who's intimately familiar with the technology. And this makes for an exorbitant cost of change, right? So this is the ending result. If you look at this, what you see is that every single designer came up with a different kind of data store behind the application. We're in the middle trying to get to our information, and it turns out that we can't get to it unless we go through the application, or at least the schema of the database behind it, right? So new information can't be captured until we have that bucket into which we put it. The data is held hostage by applications, databases, API, and we end up with this ETL hairball in the middle that consumes the vast majority of our IT budgets. We spend a phenomenal amount of money there. And slight pitch for a book that we're going to be giving away later, Software Wasteland describes this exact phenomenon. Okay, this is Dave McComb. This, just full disclosure here, this is the owner of the company that I work for. And in Software Wasteland, he talks about the nature of the problem and how insidious it is and how much we're spending needlessly on this approach. Okay? So, what doesn't change? Well, we still need to have the same things that we've always had, right? Right down to your CRUD, this doesn't change. You still do these things. You're using some different technologies, but fundamentally the same approach is what you're working with. So in traditional, mostly proprietary, open source is driving semantics, major vendor support, because after 40, 50 years, well, I would hope there would be support, right? So this is a very mature industry. We have, on the semantic side, W3C standards. These are mature, tested, and are being able to work with very large data sets in production environments. Very complex landscape, plethora of different DBMS targets. How many different database platforms do you have in your organization? Anybody? Too many. 4, somebody said. I had somebody point at their head, and I was like, what? How many hairs do I have on my head? That's how many we have. It's completely out of control. We have a simpler landscape. We have the common triple structure that we can move between DBMSs and very little implementation differences. So structure-based, wildly varying. I made up table structures for decades. Locally unique identity management, you just needed to make sure that it was unique within that table. You didn't need to have it globally unique. In semantics, it's globally unique so that you can connect it to everything else that's out there. And if you find something that you know to be the same thing, there's the ability to say, oh, this thing that's called something different than that one, they're the same. And when that happens, everything that was known about that one snaps together, and you have this huge picture of both data sets connected. Automatically assembles itself. More scaffolding than content, all your join tables and foreign keys, etc. Self-assembling without scaffolding. So getting hands-on, same input format, output format rather, different query options, structure first. You have to know the names of the tables and the columns, etc., to be able to write your queries. Question?
So the last slide, the title was data content storage, I think. Are you storing and using the data in this way, or are you semantically mapping your data?
Great question. You can do both. You can lay a semantic layer on top of a traditional data set by having the ontology direct what the meaning of those things are. There's a standard out there that I didn't talk about, which is R2RML, which is relational to our RDF. Modeling language is what it is. That's a standard that's out there. So you can do it either way. You can virtualize access, or you can import it. Oftentimes people will virtualize it just to see whether or not it's going to work. So great, good question.
One quick question on this slide. So is the premise here that the traditional data store goes away and is replaced with a semantic store, or the traditional data store will always remain and you're providing another access method to interact with the data?
Is anybody using spreadsheets to store their information, even though we've got all this fancy technology, relational technology? So no, it's not going to go away. Could it? Conceivably, but so could the spread marks. It's not, yeah. Yeah. All right, so different query options. Structure first, you have to know everything about the structure in order to be able to write queries. Meaning first, no prerequisites, because you have the ability to ask the system, hey, what classes do you have? What's in those classes? What's connected to instances that are defined as being members of those classes? Right? You can query back and forth. So looking between the two query languages, Sparkle has one language, RDF. SQL has two. Semantics doesn't make distinction between the data and the schema. You can query the schema and the data. You can combine queries that go across both. This is very powerful. You can't do that in SQL world. At least I don't know how to do that. Maybe this guy in the back does.
No, I don't. But so you're describing basically flat, independent, orthogonal ontologies that can just fit together.
Yep.
Is there anything that cross-cuts ontologies? Like suppose one ontology is a relationship, another ontology had animals and birds. Is there anything that will tie all three together in a way that properties of...
The short answer to your question is yes. Okay, so ISA exists in both. It might call it something different in the two sets, but you can say those, the ISA over here and the HASA or whatever comparable, you can say those are the same thing and then they just snap together. So short answer is yes. Obviously, I'm not saying that there's not technology learning that needs to happen here and that there isn't some complexity. What I'm saying is that when you get over that hump and you move forward, the results are spectacular and beneficial in ways that are hard to imagine from a traditional environment. Okay. RDF, et cetera. So required clauses, I don't know how much detail we need to get in here. Select, bound to variables. And on SQL side, it's bound to the physical structures that are there, right? So for SQL, you need to know everything and be specific about where in the structure that information is. On the semantic side, all you need to know is what the meaning of it is. And you can get your information back that way. Back to our question about the banks, right? There's different kinds of banks. If you understand the context, you can get it. These are the different things that can happen. I'm just going to point out a couple of the different ones. You have, in the semantic world, the ability to ask a data set, does this condition exist? Is there anybody with an account balance that's past due? And you get an answer back almost instantly, regardless of how big your data set is. It's either in there or it's not. And so you can use this to determine, do I need to go look for them? I can ask for the set of ones that are delinquent, but that's going to take longer to come back, and I might not get an answer. There might not be one. So I have the ability to ask. And I can construct things. If I learn something about the data set, I can inject that information back so that it doesn't have to do the inference to determine that the truth is there. You can materialize answers that you got out of the data back into the data set, okay, for performance reasons, et cetera.
So just, maybe you're going to cover this, but a general question is use cases. Is the assumption here that the semantic data structure could solve all use cases, or are there use cases specifically for that versus traditional data stores and data approaches?
Always the question, what can you not use it for? And it's going to be on an individual basis. I can't tell you this class of problem cannot be solved, because ideally, virtually any problem you can solve in a traditional environment, you can solve with semantics. You get benefit of additional ones that you can resolve with semantic environments. There are perhaps performance constraints on the semantic side that you don't have on the relational side. Or working with property graphs, for example. That's one of the reasons people go with property graphs, is that they're so lightweight, they don't have any overhead. You can scream through data. They're not going to go away. None of this stuff is going to go away. But can you solve a problem with a semantic knowledge graph? I believe the answer is yes, you can. And there are very large-scale systems that are out there. So looking at it from a developer standpoint, we're going to go through cell by cell to make sure these are the same. Not. This is actually a capture of my time card, and I work for a very progressive company that just wants to know what planet you're vacationing on. We have somebody who is interested in Mars, for example, and when that person's on Mars, we want to be able to know that in our data. The point here is that the output still comes out in the ways that your developers have always used it. So what developer can't populate a screen with what we see here? They're identical. If they can't do that, you need to do a little bit of recruitment, right? Because it's going to come out the same way. Now, there are additional things that you can do in semantics that you can't do in relational. Some of those we have talked about to a bit, but at the point of extraction, there really is no difference, right? So there's your leg up. When your developers go, oh my God, we can't do this. Well, actually you can, because we can get it in a form that you already are dealing with every single day. So design time logic. We're putting into the design what the logic is. It's grounded in conceptual thinking. Concepts consume no physical space. Kind of hard to get your brain wrapped around that. Triples go into a triple store, and literally it is known as a bag of triples. That is the technical term that describes it. You toss everything in there, off you go. Globally unique, we've talked about that. Reusable solutions for each concept.
Just a question, Mark. So it has to be stored somewhere. So
Yes.
I have a bag of triples.
Yes?
Consuming no physical space is a stretch. So where do they get stored?
The concepts take no physical space. The triples do.
Okay, that's what I
So
meant.
yes,
That
yes,
makes more
there is,
sense.
yes. The point is that you don't have to predefine what space is required when you come up with a concept.
Okay.
That's what the difference is, right? If you have a note field, you need to know how many characters you're going to put into it. That doesn't apply in the semantic world. You'll still need the space for it, but you say, I need a bucket this big. Oh, wait a minute, I need a bucket this big, right? So it's a detail that goes away. Good question. So meaning first in semantic, how we say things, this is what the ontology is. This is the schema. This is how we're defining what the sets are. There are partitioning strategies. People know about namespaces from XML, perhaps. This is a way of identifying that unique global identity, is that you put it in your own namespace, typically tied to your own domain name, because that's guaranteed to be unique, right? And so there are ways that you can partition the information up. This is the metadata for your system. The actual data content, what we're saying about those things that we cared about in the semantics, that is the actual data, domain specific. This is the data content that's there. And when we model it out, this is another one of these things that really blew my mind, is that, okay, what do we have here? What we have here is a conceptual model. It's a really small one, but employee is subclass of person. Seems pretty straightforward. Let's look at all the work we have to go into to do the logical model for this concept. Whoa! That looks like a trend. Look at that. There's no change. It's the same thing. The meaning is the meaning is the meaning, right? You get to physical and, oh my God, what we have here is a movement. Yeah, sometimes that works, sometimes not. You collapse these three steps, because what you do conceptually, you put into production, okay?
But you still have to have agreed on what a person is, what an employee is, and
Absolutely.
what a subclass is.
Absolutely. You do have to agree on what the meaning of this thing is, and then you define your classes and all the other artifacts that go along, that this is how you create members of the set of what your vision of for what that thing is.
And if you're snapping things together by the URIs, you still have to somehow be able to determine that this bird is the same URI as that bird. I'm talking about the same things.
There are strategies that are going to be involved in how you mint your URIs. That absolutely is part of the equation. At an architectural level, I don't want to really get into that. But yes, you do need to make sure that you come up with a minting pattern that is going to guarantee that uniqueness. But the key thing is that when you declare that I have a data record, you say that this data record belongs to that class. It is of that class. So now you've got all the birds in a class, and you can go through and make the distinction as to which specific bird you're looking for. Does that help? Sort of, maybe?
Sure.
Okay, we'll continue on. Hopefully it'll be clearer.
So just extending that, it'd be more valuable to choose the meaning because you're taking from an existing ontology that may be reusing from other ones, and you can combine external data with your own, right?
So each ontology will have its own meaning encapsulated, and they don't always agree. You will need to resolve that, just like you would in any other environment.
But if I wanted to, if I had a customer, I might want to reuse Amazon's ontology, which also has a customer, and then I may be able to combine what people buy directly with queries from Amazon, instead of having layers of indirection.
There's a couple things. Amazon's not going to let you at the data that answers those questions. But the way that it's built, you can get the information out of it. It will get too complicated if I try to resolve exactly what the capability is there. We can talk later.
How you find ontologies through reuse?
There are lots of them published. SNOMED is out there. There's a whole ton of them that are published. I went out the other day. I'm doing some research actually in the healthcare field, and I was hoping to find an ontology on ICD-10. And I was thrilled when I found one, and it's worthless. So they're out there, and finding them in organizations, one of the things we come into organizations and they already have ontologies being built by their people. And so then we look at, do they align with what our approach is, which is define the core atomic thing and inherit from that. Very powerful concept that not everybody is on board with yet, mostly because they haven't seen how to do it. Good. Yeah, I'm actually getting behind schedule here, so I'm going to kind of sail through this stuff. We have URIs on everything, partitioned with namespaces. Application refactoring is rare. You just put it in there. New tables, column mapped. You just map them in, and there they are. Database connections and queries. You can, like I mentioned earlier, include data from somewhere else. Wikipedia, Wikidata is the one that's out there publicly available. There are many others. And it's really cheap and low risk to do this. So here we go. We have Datacentric. Now we have data in the middle. The data and its schema is free to interact. Data self-assembles because it's either a member of the class that you've defined or it's not, right? So we designed what the classes are, so later on we don't need to find the tables that they're in and make sure we get all the tables that they might be in. And new information comes in. So here is an example of a bag of triples, and we have this class here, living thing, which has a subclass person, subclass customer employee, etc. We have the same thing over on the vehicle side. This is the ontology. We put it in the bag. Then we drop some data in there, and we find the things that have assembled themselves to match into these. Okay, so they're all just in that same space, commingling, and you get the information out of it. And so a knowledge graph, set of nodes linked to other nodes. Subject, predicate, object. Here's 5 triples. I'm going to kind of sail through this. But this is the way that it would look. So we have these components, the blue components. My CO is my core ontology. My D is my data. So you can see here is a query. This is information that's in there that is generated using both the ontology and the data about it, right? So they're commingled right down to the level of the storage of the information. Okay, globally unique identifiers everywhere. Ontology is a schema. We've got the metadata in the ontology. These are the things that we were just looking at from that last slide. I apologize for going so fast, but there's a couple things that I do want to get to. And we've had a lot of questions, which I enjoy. And in the ontology, both are used for that. How do we get triples? We have our metadata. We have our data. It turns out that each triple matches to one cell. So we see this corporate ID right here has CEO Larry Page. So that's how you create it. So you end up with more triples than you had rows, but it's not a problem. So no nulls required. Finally, why would you store nothing? Why do you need a receipt for something you didn't buy? Doesn't make sense, but traditional systems, you have to. Nulls are ambiguous. Requires code to interpret them, and who's trying to run queries that include nulls in them? It's a little hard with SQL, isn't it? A little bit tricky. Flags, same kind of thing. The flag itself has no semantic meaning. If I look at gender and I see 1, what does that tell me? Nothing, right? There's no semantics there. It doesn't mean anything. Boolean, why would you store two values when it's either one or the other? If it is the one, it's not the other. You know that, right? Nulls, meaningless and costly. Here's a sparse table. You've probably seen something like this. So you pull out the nulls, find the blues, find the reds. What does it mean? You don't really know. We don't typically have color. It's numbers. Have you learned anything by changing it to numbers? No. This is still pretty meaningless. And so from the dance that we do to get flags is, okay, select person, determine category, order by gender, evaluate meaning with a lookup table, or better yet, you can use a graph to get that. So we know that has gender male. That's no longer ambiguous. That's what it is. It's not has gender 1, because then I need another step. So just by looking at this, we've cut our processing time in half. All right, female, etc. Semantic data sets. Male, you say you want all the males, boom. This is the set that matches what you asked for, right? You can follow your nose. Once you've found something, you can say, oh, what else can I know about this? And everything that you could know about it just magically appears. You don't have to write a query that says find this, that, and the other thing. What else is in there that is where this is a subject? Excuse me. All right, and just in case you're curious why there's 6 genders, that's a real list, I didn't make that up. Booleans, meaningless, true, false. Yes, what? Doesn't help us at all. How about service contract signed? That tells me something. Is the service contract signed? It doesn't say that it is, so it's not. Okay? Semantically true. You don't need to go look something else up. So the Copernican future starts now. The problem, as I talked about earlier, is that we envision that the data is trapped behind applications. Well, that's the same as thinking that the Earth is in the center of the universe. It's not. The sun is. Well, now that we know that, thank you, Copernicus. The Earth revolves around the sun. Shared data ownership, self-defending data. And when I say self-defending, it's either matching the criteria for the set or not, right? If it doesn't match the set, then it doesn't come back into your return values because it didn't meet your criteria. So if you put something in there that doesn't meet that criteria, it doesn't penetrate its way into your data set because it's not true, right? There are technologies for managing what gets into your data set. Shackle would be an example of that. And again, that's a standard that's out there. That's the way you constrain what is going into it, as opposed to the ontology that defines what the nature of the class is. So it's not like the Wild West and absolutely anything can get in. You can control what comes in because anybody here ever dealt with bad data coming in that didn't match what they were hoping for? Yeah, you're beginners if you haven't encountered that. So there we go. We have our data-centric result, and data self-assembles. There should be angels singing right now or something, right? So why semantics owns the future? If we look at structure first, there's no meaning in it. Code has to be developed to figure out, oh, does this one have this characteristic? No, then move on. Does that one have this characteristic? No. Or you can say, give me the set of the ones that have that characteristic. Bam, it's already done. You don't need to do that kind of conditional logic going through it. Meaning first, you have early binding because you define what set membership is. You know in advance what the criteria is for something to come back. Precise meaning, no code branching required. Pat has gender. This is very clear, right? There's no ambiguity about Pat. Pat's gender is female. That it has the exact meaning. So how can you leverage it? Well, schema transportability. You've defined a schema that you can use as your corporate standard, and you can use it in a number of places. Pick it up and drop it on another one. What if you acquire another company and you're trying to examine what their customers are compared to your customers? You can drop the same ontology on the 2 data sets, keep them separate, and determine, does the data quality and the definition of customer that they have meet our specifications? If not, you know exactly what doesn't work because it didn't match the set. So you can look at the entries that are in there and determine where things are broken. And the ontology can help you port that, Model meanings can be imported as modules. So when I talked about a subject area, you can define that subject area and you can simply import that in the larger collection of ontologies. An ontology isn't one file necessarily, it can be, but oftentimes it's going to be multiple files that you will inherit some good work that you did over here and bring it in and be able to use it across the spectrum. And oftentimes you'll separate them by governance because the governance over customer is going to be different than the customer over or the governance over locations, right? Different people are interested in those. Questions?
So this model, back to the earlier question, lives aside from the originating data source, right? So from the system of record or the database that I'm connecting, the left side of the triple T, right? What I'm missing is there a model or a process where I can communicate changes or updates from the extracted result set back to the system I'm originally tied to? Or is this living as a mechanism for data mining?
So like any systems, you're connecting to the system by a number of means. You can do a batch extract. That's possible with semantics. You can extract the information, put it in a bag of triples, and now you have a latency issue. Is this current? I don't know, right? Or you can materialize, or I'm sorry, you can federate a view, a semantic layer over your traditional data set. And when you run the query, it will go out and say, what's the data now? It's still in the traditional system, and you can look at it through your semantic ontology. And so you can see it. There's two different technologies that are involved here, but you're not moving the data from one to the other, except in the result set.
That was my question. So
Okay.
Well, my question is, I have a result set on the data problem I want to fix.
Yeah.
Is there something in semantic that allows me to communicate that fix back to the system that I'm connected to?
Absolutely.
There is, okay.
Absolutely. That's an update query.
Okay.
Similar, I kind of skipped over the slide that talked about that. Similar to what you do in the SQL environment, you can update data. Except technically in triple stores, there is no update. You delete and replace, and you just wrap it in a transaction. Technical difference, but other questions?
I think we're out of time.
I believe that that's true.
Can we give our speaker a nice hand?
Thank you.